Okay, number 19. Says the radius is decreasing, okay, at a rate of 1.5 centimeters a second, and the height is increasing at a rate of 5 centimeters a second. So we have a shape of a circular cone, and it's just changing its shape, and it wants to know how fast is the volume changing when the height is now going to be 12 and the radius is 2. When it gets to that point, what's my volume? So we're going to use a little calculus for that. Let's write out what we know. We know that we have the radius and it's decreasing. So dr dt is equal to negative 1.5. Okay, and because it's decreasing, so you got to remember that. Negative 1.5 centimeters per second. Height is increasing, so it's positive. dh dt is equal to 5 centimeters per second. And it wants the volume, the rate at which the volume is changing. So this is what we have. And here's what we want. dv dt, and it says when h equals 12 and r equals 2. So let's see, we're going to use our formula. Volume equals 1/3 pi r squared h. And let's look at this. It has two variables. Well, three. We want dv dt, and if we implicitly differentiate this, we would have a dr dt and a dh dt, but we have both of those, and we have h and r, so we don't need to substitute something to find r or h in this case. We can just do the whole thing, but we are going to have to use the product rule, this times this. So let's differentiate it. Okay, so we would say dv dt is equal to 2/3 pi r dr dt times h plus 1/3 pi r squared, that's the first one, times this derivative of the second one, which was dh dt. And we want the volume, so we can just substitute in here. So we get 2/3 pi and times negative, r at this time is 2, so times 2. And then dr dt is negative 1.5 and height is 12. Plus 1/3 pi, r squared at this time would be 4, and dh dt is positive 5. So we're just going to punch that into our calculator. And let's see what we get. Okay, everybody enter that into the calculator. And we get negative 54.454. And that unit would be centimeters, volume units, right? So centimeters cubed per second. Negative 54.454 centimeters cubed per second. Okay, so that would be, or you could say decreasing. Okay, so that's changing at a rate of, using the negative, or decreasing using the positive. So that was number 19. Now I'm going to move on to number 21. Number 21 is about gravel being dumped onto a conveyor belt, which is our famous conical pile of sand, only it's conical pile of gravel, I guess. So you have this conical pile of gravel is being dumped out at a rate of 330 meters cubed per minute. So we have dv dt is 30 centimeters cubed per minute. It says that the base diameter and height are always the same, which I would say is a little confusing, but I think I figured it out that means the diameter is equal to the height. It doesn't mean they stay the same. That would be impossible. It means those two have to equal each other. Now, the diameter is 2 times the radius, so we put 2r equals h, so the radius is 1/2 the height. I did that because looking at this equation and what's asked for, it says how fast is the height of the pile increasing. So it wants dh dt, so that means I want to replace r and not h. And so I have it in terms of h, v in terms of h. So I replace R with h over 2. So v is 1/3 pi h over 2 squared times h. And that simplifies to 1/12 pi h cubed. By this time, you should be able to do that. Then you take the derivative. dv dt is 1/4 pi h squared dh dt. That should be easy. Substitute in what you have. I have 30 for the dv dt. 1/4 pi h would be 10 because they give it to you right here. This is the when part. So you substitute in 10 squared is 100, dh dt. Solving for dh dt, you get 120 over 100 pi, which is 6 over 5 pi meters per minute. But if you divide it out with your calculator, like they must have on the answer key, you get 0.382 meters per minute. So that was number 21.